Hey, how's everybody doing? Yes, feeling refreshed after lunch, I am. Yeah, my name's Jeff. I'm from the Ozark Mountains in Missouri. That's how I start every video. You guys were here yesterday, I heard this feel already. The reason was because I didn't know what else to say. I've lived in Missouri like 30 years. I grew up just up the road from here though. And actually the first pocket computer I ever bought, I bought from the Upper Valley Mall here in Springfield.
Can you get the volume up a little? Can't hear you.
Sorry. New computer, I got to get used to the keyboard. No, that's not advancing the slide. I'm sorry. Start the presentation. There we go. Okay. So, 1981-ish. I grew up in a little town. Everything I knew about computers was from the Radio Shack catalog. The school I went to was very small. There was about 60-ish kids in my class, right? That's it. We had a few computers at the high school, none anywhere else. So everything that my 12-year-old self knew about computers, that they were big and heavy and expensive, they were the big gray boxes, which looked like a typewriter connected to a TV. That's what I saw in the Radio Shack catalog. And one day I'm over at my friend's house, and his dad ran a machine shop, which was beside their house. And he took me over to the shop, and his dad's sitting at the desk with one of these. And I was blown away. It's like, how could that be a computer? And he used this, you know, when you got blueprints in back then, you know, because not everybody had a computer and CAD and everything, you get blueprints in, and they're made to look pretty. And there's enough dimensions on there so it's not too messy, and you can calculate any missing dimensions. So he had all his trig formulas programmed into this thing so he could calculate missing dimensions, and he manually programmed the single CNC mill they had. It was a Herco, and he had formulas in there for calculating arc centers and things like that that he needed for doing the G code by hand. And I was just absolutely blown away by this thing, and I've been fascinated by ever since. And oh, my slides aren't changed. Okay, this is weird. It's not working right, but we'll play with it. All my dates I have listed here in the left-hand corner. Those are catalog dates. So you figure in the 1981 catalog, it usually came out at the end of 1980. The Radio Shack computer catalog, you might remember it. It actually came out twice a year. There was like a spring and fall edition. So it makes some of the dates and the release dates of things a little nebulous. You don't know exactly when they released it. I didn't have time to try to go through all the sale flyers that have been scanned to see when they maybe first mentioned something. But anyhow, this was the PC-1, which was just known as the Radio Shack Pocket computer when it was released because it was the only one. And who knew if they were going to make another one, right? It's actually a Sharp PC-1211. And the first year it came out when it was first released, $249. They had it paired with a Mini Set 9 and a cassette recorder adapter. The printer wasn't available until later. And I've got, I tried to bring a working example of everything. It's over at the table over there. And the Mini Set 9 I actually got here last year and got it working. And then the next year they come out with the printer/cassette interface. A little more expensive, of course. It's basically like a cash register receipt printer. It used a ribbon instead of thermal paper. And getting it to work is a little funny. You turn the printer on, you turn the computer on, and then you press on twice more, and that redirects all the output that would go to the screen. You know, when it's outputting results, it outputs it to the printer. So it's a little odd to get used to using it. Other accessories that were available then. They come out with this neat velour plush soft-sided case. I showed this on YouTube recently, this and the one for the PC2, and people thought it was really, really sexy. Because, you know, the Sharp cases were like this boring plastic, hard-sided thing, and this is like a 1970s case, right? The cheaper cassette interface is still available. same cassette deck, and then now they've got accessories, replacements for the paper and everything for the new printer. And there was also prepackaged software on cassette available. By this time in 1982, they give this a little more prominence in the catalog. It was in color, and there were a few more selections available. And these seem to be kind of the hardest things to find anymore, is especially in the boxes, trying to find the boxed original software. The PC1 specs. And I've also tried to list the dates that everything was available, roughly. If it was different than the Sharp, I've pointed that out. Because later on that becomes a little more relevant. It was available for 3 years, a pretty good run for technology at that time, especially for a pocket computer. It had two, not one, but two 4-bit CPUs. So a dual processor pocket computer, 24-character LCD that is not dot addressable, and nearly 2K of RAM, or each had nearly 1.5K available. There they are, the two CPUs. Why two CPUs? Well, the folks making pocket computers at the time, Sharp and Casio, et cetera, had made programmable calculators for years, which used 4-bit processors generally. So they had the technology to build these processors. The ROMs they could build into chips at the time were still pretty small, so it made sense to take the IP they had and adapt it to this new use, right? So you've got two ROMs, two processors. They're each sharing what they're doing, and there's some messaging that goes on, and there is a separate display driver chips. This gives you a little bit of breakdown about what each CPU is doing. And I've got one of these now that's not working. It's not booting up fully. It's a little odd. I didn't have time to fix it before I came. It's just like, where do you start on this, right? Because the processors are passing messages to each other, and it's kind of running because it's starting to go through the boot up process. It's an interesting problem. 3 display driver chips. Since the screen isn't dot addressable, they saved a little RAM, and they use that RAM for other purposes, and this isn't uncommon in some of the later pocket computers. So the display driver chips have the buffer for the character display. The transfer buffer is the interprocessor communications. Input buffer, self-explanatory when you're typing in. And the fixed memories, A through V, when you say A equals 5, that is actually being stored in the display driver chip, which is rather odd, but that's also not unusual for some later ones. It's just, memory was so expensive, it was so precious that they used every byte that was available. Problems, if you want to get a PC1 today, the LCDs are all bad. They're either completely shot or they're going bad. They'll start turning dark around the edges, and I meant to bring one that was bad but still somewhat readable, and I brought the wrong one. I brought the one that doesn't boot up properly. So the original ones that were sold came out with the MR44 mercury batteries, which aren't any good anymore. You can use 675 or PR44s, which are a zinc air battery used for hearing aids. They're pretty cheap, so no worries, same voltage. If you try to use a 1.5 volt battery, there's you have 4 batteries in series inside the unit, so you don't want to use the higher voltage batteries. Some people will, and they'll put a diode in series, kind of modify it a little bit so that'll work. But these 675 batteries are cheap because they're for hearing aids. You get like 50 of them for $10 or something. So printer cassette interface. It has a 4-cell NiCad pack in it, which they all leak. Some worse than others. Most of them I've taken apart so far haven't been too bad, but that is something that'll need to be replaced. If you want to run without the battery pack, you got to keep in mind that internally the thing's basically running on 5 volts from that battery pack, and the charger was a higher voltage, so you have to use a different power supply, like use a 5 volt power supply with it, not the original 6 or 7 volt power supply that came with it to charge the NiCads. The next generation, it's like Star Trek, the next generation, but in pocket computers. The PC2. So this came out in 1982, so not too long after the PC1. And they started actually calling this PC2. This thing is a powerhouse. It really is. It is we'll get into the specs here in a bit. Okay, yeah, well, I'll talk about the specs when I get to that slide. But it had bigger RAM modules you could put in it. When it first came out, they had this 4K RAM module. Eventually, Radio Shack sold an 8K RAM module. You could get a 16K RAM module from Sharp. This is the same as the Sharp PC 1500. And a 4-color printer plotter was released with it at the same time. The Radio Shack part number 263605, Sharp PC or CE158. This uses the same 4-pin ALPS mechanism as the Radio Shack CGP 115, the Atari 1020, the Commodore, whatever it is. There were dozens and dozens of printers that use the same mechanism. And it's slow as molasses, but it is just awesome to watch it run. But if you think about at this time period, a 4-color printer, right, even though it's small, was amazing. Other accessories, they also had bundled software with this thing. Another sexy soft-sided case. And over here in the left-hand corner, the RS-232 converter. These are rather rare. They're great if you like programming the thing. It's a lot better, a lot faster than the cassette deck, even though it only goes up to 2400 baud. It's rather pokey, but it is still better than cassette. The accessories on these guys are a little bit interesting. Oh, we'll go through the specs first. Sorry, I'm getting out of order here. The PC2 specs, available for basically 3 years, 82, 83, 84, same as the Sharp PC 1500. 8-bit CPU, 1.3 megahertz. It is a Sharp LH5801. This is a processor that Sharp developed. It's not a Z80. You'll often hear it referred to as a Z80. It's not. Completely different instruction set that is somewhat similar to a Z80. There's some things that's more similar to a 6502. It has 2 pages of opcodes. So there is a lot to it. Came with about 4K of RAM, but you could expand that up to 16K. And the 24-character LCD is dot addressable. You can set and turn off every dot on that display. When I was trying to figure out how to control the display, I came up with this graphic. And yes, it is that complicated. I'm not going to try to take the time to explain this right now because I would confuse you and I would confuse myself. But basically, there are 2 separate memory banks starting at 7600 and 7700. In each column, the top 4 bits and bottom 4 bits are from separate bytes. So you have to do all this transmogrification of what you want to put on the screen to get it into the right bank and the split between the right bytes. Yeah, why it has something to do with the way they laid out the display driver chips for them to be more efficient. The interesting thing about the accessories on this machine is the accessories generally contain their own ROM. So when you plug the accessory in, you now have more basic commands, which is very cool. It also means that you can't develop programs for that accessory without the accessory plugged in because you can't. It doesn't exist. You can't really read this memory map, but that's just sufficient to say, yeah, it's kind of confusing. It could address up to 128K with some bank switching that was built in. Before, there was a lot of really good technical documentation available from Sharp or Radio Shack. This unit was reverse engineered. People figured out what the opcodes were, how they worked. It was written about in magazines. And what this led to is 3 or 4 different sets of mnemonics for this one processor, which if you're starting now and trying to go back and learn and read stuff from magazines, it makes it super confusing because, people called things different things and there were slightly different explanations of how things worked. And yeah, so when I do things, I try to stick with the Sharp mnemonic set because it's like the best documentation there is, even though there's errors in Sharp's documentation. But you can program this guy in assembly. It's one of the few that you can, which lets you do fun things like this. It has a 50-pin connector on the side that you can get a mating connector to today. There's a guy in France that came up with these breakout boards. which I connected to a prototyping board. There is a little EEPROM behind that. And there's just a couple 7400, it's like an AND gate and an OR gate or something like that for decoding logic. Yeah, I'm just pointing out the EEPROM there. And you could do fun stuff like this. This was supposed to be a video, but I don't think it's going to play. Let's see. Oh, there it goes.
We are running the one column at a time screen invert off of an external EEPROM. Check it out. Using this little breakout board. Yeah, it's out of focus.
Okay. Anyhow, that was a lot of fun to figure that out. And it gives you a lot of possibilities with creating your own stuff for the device. Back in the day, there were companies in Germany and other places that made like industrial controller types of things that ran off of this computer. So you could plug in a PC2 or the PC1500. It's a pretty amazing little machine. Today, if you want to get one of these, and it's my favorite, by the way, problems to look out for: AA battery corrosion. That's a problem with everything. The NiCad pack and the printer/cassette unit, those will either not be much of a problem at all, or it destroys the entire thing. I've seen them both ways. And if it's really, really bad, there's a flex cable that goes from the connector down to the circuit board. It gets under that thermal adhesive bonded flex cable. And yeah, it's bad. So, and you never know. If you're buying one online, you don't know what you're going to get. Sometimes you can see some corrosion on the top or the side of the unit, and it may be okay inside, and it may be trashed. Printer gears. The pinion gears on the stepper motors for all the ALPS mechanisms are cracked. It depends on how bad they're cracked, but everyone I've seen has been cracked. There are replacements available. I tried for a couple of years to find somebody to make replacement gears, and I finally did. The pins for the printer can also be difficult to get. There's a German company that makes new ones, a medical device company, because they also use this ALPS mechanism in a lot medical chart recorders, a lot of those. I did happen upon a bunch of pins and a lot of stuff I bought, so I have a few. The NiCad battery pack and the RS-232 interface, that's another thing to watch out for. Most of them I've seen have not been too bad. I just got a hold of one that did a lot of damage inside, and I still haven't got it running. But mostly on the NiCad packs, I build replacement nickel metal hydride packs. The way these things charge, all these old battery powered things, they don't really have any charge control circuitry. You plug the charger in for a certain number of hours and then unplug it. If you keep it plugged in all the time, you'll boil the batteries dry. So, and most of the manuals will say something like, charge it for 8 hours and take it off. Some old computers will have like a low battery light. So you wait till that comes on and then you plug the charger in, that type of thing. Now we're getting into the later generations of stuff. This is the PC3. This is a much smaller unit. It's actually the first one that's probably shirt pocket sized. The keys are a little small and square for my liking. It's the same as a Sharp PC1250 or PC1251. The original, which is shown here, came with 2K of RAM. The later one came with 4K of RAM, which is how you can tell them apart. Otherwise, they look the same. Came with this nifty cassette printer interface. And the specs, available for a few years, released a little after Sharp. The original had 2K, but the later one had 4K. It was an 8-bit CPU at about 0.5 megahertz, 24-character LCD, not dot addressable. Pretty good sized display for the size. One oddity of this that you won't see in any other pocket computers really that I've seen is it has a removable ROM-RAM circuit board. But you take the cover off to change the batteries and there's this circuit board. And it seems very puzzling at first. And that was done because Sharp made a run-only version of this particular unit. If you went into like a car dealership in the 80s, early 90s, and they were doing the loan calculations, they may have used a unit like this. You know, there was a place that would write software that would do that financial stuff, right? It would be packaged with the computer. There was an overlay on the keyboard. The keyboard had less keys on it. So, and you'll see some of those on eBay now, and you'll say like Ford Motor Credit or something like that on them. This same unit, the basic does include peek, poke, and call. So people did figure out how to do assembly language. None of that was officially from Sharp. People made their own homebrew assemblers, and they figured out that on that RAM-ROM board, there was a lot more address lines than what were being used, and they took the 2K RAM chips off of there and put like a 16K or 8K on there, whatever they could get, and wired it up with a bunch of bodge wires, and it works. So it's a very capable little machine. The keyboard's not my favorite. PC3 problems. Generally, they're not too bad. The coin cells generally don't corrode that bad. They can, so still, if you're not going to use the thing, take the batteries out. Or what's the thing? Get the damn batteries out or something like that. There's a saying like that going around. The LCDs on these can go bad. And thankfully, like the PC1, the same guy is making replacements. Did I mention that before? The PC1, you can replace the LCD. Anyhow, they are available. New LCDs are available. They work great. They're not too difficult to replace. Whereas all of the PC1s have a bad LCD, maybe 25% of the PC3s seem to. Then we get into the PC4. This is the first Radio Shack sold unit that was made by Casio. And it is not as powerful or have as much memory as the PC3, but it has a nicer keyboard. I have one of these on my desk at work every day. It's just a nice little computer. So it had a separate printer and cassette interface, but the printer will kind of piggyback on back of the cassette interface. So you can have them both connected at the same time, or if you don't want the cassette interface, it has like a little ramp that you can set the computer on so it'll line up with the computer. The cassette interface is battery powered. The printer is not. You need a wall wart for that. Nice little machines. There was also 2 versions of this released. The original version was the same as the Casio PB100, and the later version was the same as the Casio PB100F. The original version, if you take it apart, you'll notice there's a little bodge board by the processor that wraps all around it. There was some type of write timing issue with the RAM, and it would scramble the RAM at power up every once in a while. So they added that bodge board. When they fixed the processor, they took care of that problem. You could get a huge 1K RAM expansion module. These guys are impossible to find now. If you find a computer that has the 1K in it, consider yourself lucky. And it has a little soft-sided case thing like this, which is kind of nice. You can slip like the printer in there with the computer. The specifications, it was also available for a good period of time. It's slower, only a 200 kilohertz processor, 12-character display, smaller than the PC3. Has the stock unit has very, very little RAM available. It's also a 4-bit processor. I think the next slide is, yes, okay. This is the bodge board I was talking about. That's in the original units. And it won't be in the later units. So these older Casio-made systems are interesting because it's basically a single chip. Besides the RAM, it's a single chip system. There's one chip that's a processor, an LCD driver, and everything. There is a 4-bit bus that comes out of the processor. You can see it basically coming out of the top of the big chip on the bottom there, and the chip at the top is the processor. Chip at the bottom is the 4-bit RAM chip. And that 4-bit bus goes to the RAM chip or RAM chips if there happens to be more than one, and it also goes outside to the expansion connector. So when you're plugging accessories into these guys, you're plugging into the main bus of the computer. And I've been trying for months now to make a PIC microcontroller act like a RAM expansion for these guys. And I got it pretty much working, and I noticed that with the earlier models of these, when I was plugging that in, when you turn the computer on, it like pulls to see how many RAM devices respond. And the original model assumes device 0 is there, and it looks for device 1. And if device 1 answers it, it just gives up. It's like, okay, I've got 2K. And when you press the reset button, it'll actually reset all the tables and pointers and stuff in the machine to tell it how much memory is in there. The later device, the one based on the PB100F, does things a little differently. When you turn it on, it pulls for device 0 and then device 1, and then it tries for device 2. I don't know yet how far that'll go, but it looks like it will support more than 2K, which would be kind of interesting. And it leads to some interesting things because you can access the bus and twiddle things directly. You know, you can like read and restore the RAM directly. Kind of an interesting deal. So here's the little setup I did with the PIC. So the connector is a homemade deal. That was a lot of fun to figure out how to make. And the processor, when it's just running like this and you're not typing anything or running a program, it goes into idle states that are about 3.5 milliseconds long, where the bus is in a high impedance state, so you can directly talk to the RAM. PC4 problems. I've not seen the LCDs fail, but if they're not stored in a good condition or it's too wet or too hot, the polarizers will start to separate from the LCD glass and they'll darken around the edge. You'll see like a halo around it, or it'll look really dirty or speckled. Most of the time the LCD itself still works, but the polarizer is detached. I did like a redneck fix on one of those using a polarizer pulled off a PC3 and some white paper as a reflector, and it kind of worked. It was a little better. And I bought the real polarizing film, but I haven't tried it yet. The RAM chips we were just talking about, those do fail. Those are impossible to get except from another calculator. Casio used those 4-bit RAM chips with an interesting protocol, and they used on some machines a 4-bit ROM like that, also unobtainium. Now we're getting into, this would have been more like my high school era here. The PC5, PC4 still available, PC3 was actually still available. PC5 is another Casio-made unit. It's this clamshell design, has the membrane key on, the alpha keyboard on the top, which a lot of people really hated that membrane keyboard. When you're programming, they kind of act like hotkeys, so it's not too bad. I bought the next version of this, the PC6, in high school, and I thought it was awesome. But I also had a Timex Sinclair 1000, which I spent hundreds of hours typing into a crappy keyboard. So this PC5 was one of 2 Radio Shack Pocket computers that was only available for 1 year. Then we had the PC6, which looks just the same. Whereas the PC5 had 4K and only 4K, and you could not expand it from 4K ever. This came with 8K, and you could expand it to 16K. Otherwise, functionally, they were the same. So I've combined the specs on these because they're generally the same except for the RAM. This also had 2 4-bit CPUs, and these CPUs also drove the display. There was no separate display driver chips in here. They shared the duty doing that. They are both mounted on the upper keyboard side of the unit. Both processors are there. 24-character LCD, not dot addressable. PC5 had a memory limitation. They weighed the same. They're the same size, roughly. We're back to this Casio 4-bit bus. The PC5 used the same 4-bit bus. And since each RAM chip was only 1K, 1K bytes, it was 2K nibbles. They stuck 4 of them in the PC5, and how many are going to fit in that little thing? And all those are going to use power. And it was kind of, they were really constrained there. In the PC6, they came up with this, what's shown as the IC4 here. This is a custom ASIC that converted the Casio 4-bit bus to use a standard 8-bit parallel static RAM. They solved the problem. They kept the same IP with the processors that was already working fine. They added this one chip, and they could use cheap, readily available RAM. Yep, here's our 2 4-bit CPUs, and you can see the lines coming from them out to the Casio bus to the same expansion connector, and then everything going up is going to the LCDs. And they're also sharing tasks and talking to each other and that type of thing. So this gives a breakdown of what the CPUs do. It's interesting. Both CPUs have a clock generator built in, but one CPU is wired to feed the clock into the other, so they both share the same clock. And that is only sent out to that interface IC, the RAM interface IC. It also gets the same clock signal, but that clock is only sent out to the rest of the system, to the expansion port and everything, when it's running or you hit a key. Otherwise, why twiddle bits and waste energy when you don't have to? Oh, and that special gate array chip that also controls the buzzer, which is kind of interesting. PC56 problems. The PC5s are rare. I looked and looked and looked for one. I finally found one, and it had a broken latch, so I had to 3D print a replacement latch. The PC6 are like belly buttons. Everybody seems to have one, right? They're everywhere. They were made for a long, long time. They were used by businesses for like doing stuff in the field and everything. The hinges will always split, right? There's a metal hinge pin through a plastic piece that's rather thin. They split, but they still work. No big deal. The latches break. I made a little 3D printed thing. I put it up on Thingiverse so you can download it and print a replacement latch. And the 8K expansion modules for the PC6 are also very hard to get. I actually made a 32K module for a later Casio, which should fit and work in here, but the PCB on this particular computer, on the PC6, is so thin that it warps under the pressure of the zebra strip. So I've got to figure out how to overcome that. It wouldn't give it 32K. It can only address the additional 8K, but at least it would be a solution. 1987, the PC7 came out. Why? Nobody will ever know. I mean, I kind of like the form factor, this kind of like portrait wallet folding open thing with the alpha keys on the right-hand side. The membrane keys on the right-hand side here, if you thought the PC5 and 6 was bad, PC7 says, hold my electrons. I'm going to do that, twice as bad. And, oh, okay, sorry. I forgot what that page was. That page that was blank, that was the entire catalog of accessories and prepackaged software and everything that was available for the PC7. Because there was nothing, because there are no external connectors on the entire thing, right? So if you type programs in there, sorry about your luck. The batteries go dead, there's no backup, right? You change the batteries, you lost all your programs. The other thing is, it was based on the Casio FX5200P, which came out in '85. Well, Radio Shack released the PC7 in '87. They sold it through '89. And evidently it was a good seller because they had it, basically in 3 catalog years. But, this is basically the, you notice the 4-bit CPU at 200 kilohertz? Well, that is basically the same inside as the Casio FP100/PC4, right, in a different form factor with no expandability, no mass storage. And it was $10 more expensive. But evidently people loved it. I have read that some of the PC7s came with the extra 1K chip soldered onto the board. There's always a place for it on Casios. Mine actually has the expansion in there, but they were always listed in the Radio Shack catalog as having 2K. Yep, this is mine. It has that already built in. Underneath there, where the module is, there's a sheet of plastic, and if you peel that plastic up, there's a footprint for the RAM chip. $1988. PC8. This was another one-year wonder. We wonder why they came out with it when they did. This was a Sharp computer, and you could use the existing cassette printer interface from the PC3. Still worked with this guy. This was pretty cheap. It was small. It's not terrible. It has the same tiny buttons as the PC3. Yeah, it was available from 1988 all the way through 1988. It was basically a Sharp PC 1246 from 4 years earlier. And if you think about in the 1984 computer years was a long, long time. It did have a fairly fast processor though, right? 4-bit, 1 megahertz, that's pretty fast for a 4-bit processor. Small LCD, not a lot of RAM, and evidently they didn't sell too many of them. It'd be interesting to know what those numbers were. Like the PC5, the PC8 is hard to find because they didn't sell many of them. They seem to be, the ones I've seen seem to be in pretty good shape though, whereas the PC5s, PC6s tended to get beat up a little bit. Questions?
I noticed that they came with a lot of software for the PC1. Didn't see much after that. Was there backwards compatibility between the first three?
The PC1 and 2 were both Sharps, as was the PC3. They were kind of similar flavors of BASIC. Not exactly 100% compatible. There was software available for the PC1, 2, and 3, and then none after that. None of the Casio models or the later Sharp models had any software available. Yeah. Oh, excuse me just a second. I forgot to repeat the question. He was wondering about software availability for all the models. Go ahead, please.
Okay. No, curious about there is any story behind changing from Sharp to Casio and back to Sharp. Do you know
Okay.
anything about it?
The question was there any, has there been any rumors about the change from Sharp to Casio back to Sharp? I have not read anything. Radio Shack had some things custom manufactured for them, and they rebadged a lot of things. And my suspicion would be they were choosing what they thought would sell in the marketplace. And for Casio and Sharp and those manufacturers that were making stuff private label for Radio Shack, they were getting a huge distribution network. So it made sense for them to sell it that way, even though they were selling these same models under their own brand name in the US.
What kind of programming tools are available for the model PC2? Like, are you stuck with the built-in thing, or is there some kind of cross-assembler, or how do you?
PC2 programming, that's a very good question. There are some external tools available. There is a program, I can't remember his name, a guy in France called LH Tools, which is pretty good. I've written a disassembler and a emulator for the processor. It's not complete, but it's somewhat functional. I wrote the disassembler because I was trying to disassemble the RS-232 interface ROM, and the disassembler in the LH Tools wasn't doing what I wanted. And that was like 80% of the way there to getting an emulator for the processor itself, so I went ahead and did that. So there is also, the LH Tools will also function as an assembler, and I wrote an extension for the telemark assembler, TASM, that from back in the day. I got a hold of the author of that, and he's maintained it all these years. So I paid him for a license, and I added some addressing commands to calculate jumps properly for the LH5801. It does, most processors, when you do a jump in assembly language, you have a byte that is, direction and magnitude. The bit 7 is the direction, and you have so many addresses forward or back. The LH5801 can go a full bytes jump 255 spaces either direction. And so encoding that is a little different, and it's not a normal addressing mode you'd find in most other processors. So there's problems with both of those programs, the one I wrote and the one the other guy wrote, because a lot of the documentation wasn't great. There's some things that Sharp had backwards in the manual. There's some things I just didn't understand when I was writing it, how it worked. You can, with the RS-232 interface, you can redirect the keyboard to the terminal and the input from the terminal back to the machine, so you can basically use a terminal window on your desktop to talk and program to the computer.
What if you don't have an RS-232 interface? Is there some option there?
No. You're stuck with a cassette, which is kind of bad. Yeah, a friend of mine and I were kind of looking at trying to do a modern spin on the RS-232 interface because they're really hard to get a hold of. So I finally found one in Japan. I sent him, so we both have one, so we can try to come up with something. Yeah, so if you can find one, grab it because they don't stay around very long. But it is a cool machine. The Gerbers for that breakout board are available. I can get you the part number for the connector, things like that. I might have some breakout boards with me, I don't know. But it's a fun machine to play with. Anybody else?
Did Casio or Sharp produce any pocket computers after '88?
Yeah, did Casio and or Sharp produce any pocket computers after that? Yes. Some in the US market, they sold some in the European market, a lot in Japan. It seems in Japan they used the pocket computers for teaching tools in technical colleges and universities. And so, if you were learning programming, you had your pocket computer and you learned to program on that. When I got the PC-6, one thing that really confused me is I read in the advertising, program in an assembler, and I thought, that's cool. Well, I got it. Well, it was an interpreted assembler. And I thought, well, this is stupid. This isn't machine code. I'm not writing in assembler. I'm writing in something that's harder but slower than BASIC. Well, they call that CASL, C-A-S-L. It's like Casio Assembly Language something. But it was designed as a teaching tool for universities, right? So you would learn programming on that. You could program in BASIC or machine language. They come out with several models, kind of along the size and functionality of all these different things. In the PC2, which is the same as the Sharp PC1500, they came out with the 1500A, which was very similar. It had a slightly rearranged memory map that was a little better if you wanted to program in assembly. They came out with the PC1600, which is like the top of the line Big Daddy pocket computer. I think the 1600U was the last one they made in that line, which the retail price when it came out was like $700. It was serious. They had the menu boards they use at fast food restaurants. It's like the keyboard, and it's like, just touch, I don't want a cheeseburger, that type of thing. They called it a software board like that, available for the PC1500. And you could put your own overlay in there and plug it into the computer to that 50-pin connector and use it like that. So, a lot of stuff up through into the 90s. I'm not exactly sure when that ended, mid to the later 90s.
And do you collect them or just stick with Tandy?
No, I collect all of them. Recently, I bought a Panasonic, which is the first Panasonic I've ever bought. I haven't taken it apart yet. I just got it before I came here, so no idea about it other than it seems to be pretty robust. And it had a Farm Bureau sticker on it. So it was used for like insurance or something like that. Any other questions? I did try to bring a working example of each Tandy branded computer today. I've got them back at my table if you want to see it. Play with one, turn it on, program it, that type of thing. Okay, that's it. Thank you.